Hello everyone. This is the second part of the surface area scale factor. So hopefully before you watch this video, uh, you tried completing this table and solving for the original surface areas of B, C, and D, as well as the new surface area. So in this video, we'll no longer show that one. Again, you are free to go back to our previous video wherein we get the surface area of the rectangular prism A. So, or we'll give you an additional video clip on how to get the surface area of a rectangular prism. Again, in a rectangular prism, there would be 6 faces, and distinctively there are 3 in total, because the top and the bottom would have the same dimensions, as well as the front and the back, as well as the sides. They will have exactly the same dimensions. So therefore, in our previous video, we tried to multiply the area that we get for the front by 2, because there would be front and back, as well as the top and the bottom and the sides as well. So again, I'm just gonna give you the values of the surface area of the original prism as well as the new surface area. So for rectangular prism B, you should get an answer of 468. Again, the unit is cm squared. So you're going to get the value of that. And then to get the different dimensions, just like what I did earlier, you actually just have to multiply this 1/6 here to the different dimensions. So for example, for the first one, for the length, it's 9. So to get the value of the new length, it would be 9 times 1/6. Okay? So if you have 9 times 1/6, that gives you 9/6, or 9 divided by 6, that gives you 1.5. So the length of the new prism would be 1.5 centimeters, and then the width would be 6. If you're going to multiply that one by 1/6, that gives you 1, because 6/6 is just equal to 1. And then for the last dimension, this could be height, or this could be the thickness. So 12 times 1/6, that gives you 12/6. So that gives you 2. So these are the new dimensions now: 1.5 by 1 by 2 centimeters. So 1.5 centimeter by 1 centimeter by 2 centimeters. So if you're going to calculate the surface area of this using these new dimensions, you should get an answer of 13 cm squared. So now to get the area scale factor, again, it's just the ratio of the new surface area all over the original surface area, or the image over the original. So that would be 13 all over 468. So that would give me an answer of, if I'm gonna divide both by 13, Okay, that gives me 1 is to 36. Again, if you're wondering how did I get 1 is to 36 there, that is just by dividing 13 by 13, so it gives me 1. So 13 divided by 13 gives me 1. And then 468 divided by 13, that should give me a value of 36. So that is why I can also write it in ratio form as 1 is to 36. Okay, so going to letter C, so the rectangular prism C, if I'm gonna get the surface area of this, again taking the sum of the area of each face, it should give me 184 cm squared. So again, to get the new dimensions, I'll be using this linear scale factor 3 halves. Okay, so I'll be using the linear factor 3 halves to get the new dimensions. So that would just be 4 multiplied by 3 halves. So that would give me 12 over 2, or that is 6. Then the width would be coming from the next number of 8. So 8 times 3 halves, that gives me 8 times 3 would give me 24, divided by 2, that gives me 12. Okay, so the new length would be 12, and then the new width, and then for the height it would be 5. So that would be 5 multiplied by 3, 15, divided by 2, that's 7.5. Okay, so these are my new dimensions, and if I gonna get the new surface area of this rectangular prism with these new dimensions, it should give me an answer of 414 cm squared. So again, if I gonna get the value of the surface area scale factor, it is just the ratio of the new surface area, which is 414, all over the original surface area, which is 184. Okay, 184. So if I'm gonna simplify this one out, it should give me a value of 9 over 4. Okay, so this should be 9 is to 4. Okay, so 9 is to 4. So I'm just trying to reduce the fraction 414 and all over 184. So again, what I did there is just simplifying my fraction. So actually, if you will check, both are divisible by 46. So therefore, 414 divided by 46, that should give me 9. So again, this is that divided by 46 gives me 9. But if I want to again retain the equality, I need to divide also the bottom part by the same number, 46. So 184 divided by 46, that gives me 4. So again, I'm just trying to simplify my fraction here. So I'm getting the greatest common factor between 414 and 184. So it turns out to be 46. So it gives me 9:4. So that's my scale factor, the surface area scale factor. So now moving on to the last rectangular prism. So with these dimensions, again, if I'm going to get the surface area of this should give me 252 cm squared. And going to the new dimensions, I'll just be using this linear scale factor. So again, this is a reduction of the different dimensions because this is less than 1 at 2/3. So you're going to expect a dimension that is less than my original dimension. So for example, in this case, originally I have uh, a length of 3 centimeters. So if I'm going to multiply that one by 2/3, that gives me 2 centimeters. And then the width, so I have the width of 12. So if I'm going to multiply that one by 2/3, that should give me 8, because 12 times 2 is 24, divided by 3, it's 8. And then I'm going to multiply, no, again, this is just a notation, noting the different dimension. 2 by 8 by, well, 6, the last one, it's 6 times 2/3, that gives me 12 over 3. So 12 over 3 is 4. So this would be my new dimensions, 2 by 8 by 4. So if I'm going to get the surface area of this, it should give me an answer of 200, no, not 200, but it should be 112, okay? So it should be 112 cm squared. So if I'm going to get the surface area scale factor, surface area scale factor, that would be 112 all over 252, okay? 252. And if I'm gonna simplify this one, this should give me an answer of 4:9. So 4:9. And how did I get 4:9? Well, if I'm gonna get the greatest common factor between 112 and 252, both are divisible by 28. So if I'm gonna divide 112 by 28, it gives me an answer of 4. And again, to retain the value of this fraction, it will also divide the bottom part by 28. And if I'm gonna do that, 252 divided by 28, it gives me an answer of 9. Okay? So now if you try to examine what is the relationship between the linear scale factor and the surface area scale factor. So if you're gonna do that, is it not that the surface scale factor is just the square? So again, just the square of the linear scale factor. Or again, from here, if this is their surface scale factor, is just equivalent to the square of the linear scale factor. So it also follows, therefore, that the linear scale factor, if you know the surface area scale factor is just the square root of this surface area scale factor. Okay, so you can have these two relation based on the of this particular table. Okay, the surface scale factor is just the square of the linear scale factor, but also it follows that the linear scale factor is equivalent to the square root of the surface area scale factor. Okay, so if you have any questions, so uh, you can ask me in class during our session.